everyone, welcome to our application video for 1-17. It is on rational versus irrational numbers. Before we get going, I just want to congratulate you guys for reaching the last video in Unit 1. This will conclude our video series for the first unit. Don't worry, we'll be back again in the second unit with a new series of videos, but just wanted to congratulate you for reaching your first kind of milestone in this series. After this application, you will have the one more mastery check to go over with rational versus irrational numbers, and then you're going to pick up a study guide from your teacher, and you're going to use this as a study tool for your Unit 1 test. When you have completed the study guide and you've asked any questions that you have and you feel prepared to ace the test, like I'm sure you're going to, you'll let one of us know about a day in advance. That way we can schedule you for your first test. Just a reminder, you do need to make a 70% or above on that test to move on to Unit 2. If you don't, then we'll go back and review with you and figure out what you missed on that test and get you going for a retake of a different version. Alright, I just wanted to congratulate you guys one more time and just let you know what's going to be happening since this is our last video. And without further ado, let's go ahead and jump into the video. Alright, just to recap our learning targets, they are kind of lengthy for this particular lesson. They are, I can distinguish between rational and irrational numbers. I can explain why the sum or product of rational numbers is rational. I can explain why the sum of rational numbers and irrational numbers is irrational. And I can explain why the product of non-zero rational numbers and an irrational number is irrational. So, in our application, we're asked to experiment with the sums and products of two numbers from the following list to answer the question that follows. And we're given a string of numbers. We're given 5, 1/2, 0, the square root of 2, the negative square root of 2, 1 over the square root of 2, and pi. And we are asked to evaluate whether a certain group of statements are always true, sometimes true, or never true. And we want to show calculations as our evidence to our decisions. Alright, so we are given the problem. The sum of an irrational number and an irrational number is irrational. And we're looking at problem number 3. So you'll want to look at problem number 3. Again, it's the sum of an irrational number and an irrational number is irrational. And we want to evaluate whether this is always true, which means no matter what numbers we're going to choose, it's always going to work. Whether it's sometimes true, or whether it's never true. So let's just focus first to see if we can find one that is true. So we're looking at the sum of an irrational number and an irrational number. So we want to look at our numbers that are irrational. So let's focus in on these numbers here. So to start out with, let's just try the square root of 2 plus pi. Now, I want you to just go ahead into your calculator and try the square root of 2 plus pi. And there should be a pi key on your calculator. If you need help finding it, let us know. But when you do the square root of 2 plus pi, you're going to see that the answer comes out to be something like this: 4.5558062, and then my calculator rounds it to 1/6. It might be a little bit different depending on how many decimal places your calculator rounds out to. But it's going to keep going forever and ever, and you can see that there's not really a clear pattern in this. So we did get an irrational number when we did the square root of 2 plus pi. So we know it's not going to be never true, because we found at least one example where the statement is true. Let's see if we can find an example where it's false. Now I want to think back to my properties of addition. Now I had something called the additive inverse. And what that told me is if I added a number and the opposite number, it gave me 0. And 0 is a rational number. So let's try that with some of these numbers that we're given. I'm given the square root of 2, and I'm given the negative square root of 2. So we have a number and its opposite added together. Now, if we think back to that property, the additive inverse, this should come out to be 0, but if you want to be sure, type it into your calculator, the square root of 2 minus the square root of 2, and you will find that it is indeed 0. As we said before, 0 is a rational number. So, since we added two numbers on this list, they were both irrational. The square root of 2 is 1.14, and then it keeps on going. And the negative square root of 2 is negative 1.414, and the decimal keeps on going. Those are both irrational, but in this case, we do have two irrational numbers. They're going to add to give us a rational number, which is 0. So we can say that the sum of an irrational number and an irrational number is irrational sometimes. So this is sometimes true. So go through the rest of these examples. Play with some numbers from the list above, up here. See whether you can prove that they're always true, sometimes true, or never true. Good luck with the application. When you're done, take your mastery check and get with your teacher to talk with them about a study guide and scheduling your test. Alright, see you guys in Unit 2.